background. Imagine you have NaCl, we call sodium chloride. Sodium what? Chloride. Sodium chloride is a solid. Is a what? Is a solid. Now, for you to write the KSP expression, now therefore you must split this one into its various ions. Do you understand? So what makes that salt? Now the ions that make up that salt. If you check very well, it is made up of what? Sodium and chlorine. What is the oxidation state of sodium? The oxidation state of sodium is what? Na plus. Do you understand? Then the oxidation state of chlorine is what? Cl what? Minus. So when these two combine together, it forms this sodium chloride. How do I know? So remember, when writing ionic formula, you make use of the oxidation state, which is Na, which is what? 1, Cl, which is what? 1. You move here, so you have NaCl. Do you understand? So when writing KSP expression, the first thing you want to do is to what? Know the oxidation state of what? Of the species that form that salt. You get, like here was sodium chloride. Now here we have Na plus and what? Cl what? Minus. So once you have done that, you write what? A chemical what? Equation. So you write a what? A chemical equation, because it's a reversible what? Reaction here. So it's going to be what? Na plus. Do you understand? Now this one is a solid. Now the ion is what? Is aqueous plus Cl what? Minus aqueous. Do you understand? Now what means that when this one satuates in water, it's going to form two ions, a positive ion and a negative what? Ion. Do you understand? You always form what? Ion. Now the next thing I want to do is what? Balance the chemical equation. So how many sodium do we have here? Here we have one sodium. Here we have one sodium, one chlorine, one chlorine. Do you understand? So it means that the equation is balanced. So for you to write a KSP expression, therefore you must write a balanced equation. Do you understand? Now the next one to do here is to what? Write the KSP expression. Now the KSP expression is always KSP equals to what? The anion. So it's going to be what? Constitution of cation. Cation always about coefficients. Raised by what? Coefficients. Okay. Concentration of what? Cation raised by what? Coefficients. Then concentration of anion raised by what? Coefficients. Sorry. Let me write like this. So KSP equals what? Concentration of the cation, which have to be the first one, raised by what? Coefficients. The concentration of anion raised by what? Coefficients. Now, when writing KSP expression, you don't make use of solid. You understand? So this is what? This is the what? Easy formula to write KSP expression. So it's going to be KSP equals to what? Now the anion is what? Na plus raised by what? 1. The coefficient is what? Is 1. So but then point of putting the 1, right? The next one is what? Cl minus aqueous raised by what? 1. Do you get that? So this is what the KSP expression for this what? Reaction, for this what? Salt here. As easy as that. I'm making a mistake here. It's supposed to be 2. So now let's dive here. Let's start writing the KSP for those compound here. So let's take the first one. CuBr, right? Now, how do you write the KSP? The first thing you want to do here is to what? Split this one into its what? Various ion. Right there. And we have copper, we have what? Bromine. Right there. Now the oxidation state. Now the easiest you want to do here is to what? Try and look for the oxidation state of one of the elements. You get that? If you can look for the oxidation state of one of the elements, you can easily get the other what? Element. Do you understand? So understand that bromo is always what? Br what? Minus. Right there. Br what? Minus. Now if bromo is always Br minus, say then copper be Cu plus. Can you see that? So the oxidation state of copper and bromine is what? Minus 1 and what? Plus 1. So that now that is what first you want to do here You get that's the first thing you want to do. Figure out the oxidation state of the what of the elements that make up what that compound. Right there. If you can figure out the oxidation state, then it's more easier for you to what write what the equation and balance it and write the KSP expression. Do you understand? So in this case here, it's very easy because bromine is only what -1. Copper is only what is copper can either be +1 or +2. But in this state, copper is +1 because when you write the ionic equation with these two here we have Cu, which is what 1. This one because of +1. Then Br is what is 1. Because what -1 here, right? If you write it here, this one move here to form Cu1 Br1. Right there. So then no point put the one, so going to be Cu B what can you see that? So that's why we are also here. So first you want to do is to what? First you want to do is to what? Figure out the oxidation state of what? Of the element that made up what? That are made up that are in what? Or that are made up that or such. So after that, you want to write what the chemical equation. So it will be Cub what R, which was solid because salts are solid. So here we have Cu2 plus, which called the aqueous, right? So Cu plus, right, plus Br minus. This is that. Now the next you want to do here is what to write the balanced chemical equation. Already is balanced. This is what balance. So here, since it's balanced, so you just want to write. Remember that Ksp equals what? Constitution of the cation. This is our coefficient, right? With our coefficient, let it be like that. The constitution of an ion. This is what coefficient. Just like that. So that in my Ksp here going to be consider Cu2 plus aqueous, right? So plus, not plus. Then here we have constitution of Br minus aqueous, right? That is it. This is what the KSP expression. Now let's move forward to the second one. So if you should look at the second one here we have CaF2, right? Now, like what I told you here is that you must figure out the oxidation state of each of the what elements. Here we have calcium, here we have what fluorine, right? Now the oxidation state of calcium is always +1. You get because they always what lose 2 electrons, right? So it's going to be Ca2 plus. Now the oxidation state of fluorine is always what -1. Can you see that? So how are you going to do it here? Now, if you should write the ionic equation with this one here, you have Ca, which is what 2, F, which is what it's 1. Then carry some move here, carry to the other side here. So you have Ca1, F2. That is how we got this one here. That this calcium fluoride is made of what? Calcium 2 plus and fluorine what? Minus. Do you understand? So, like what I said, figure out the oxidation state. Once you figure out the oxidation state of each of the elements, then it's more easier for you. Now, in case you don't even know the oxidation state, understand that this one rightfully belongs to this guy, and these two are rightfully belongs to this other one here. Do you understand? So there are different ways you can actually what figure the art. You get so this is one of the way I'm teaching you now. So yeah, now I have what Ca2 plus aqueous plus what F minus aqueous, right? That is it. Now the next thing you want to do here, is what? To write a balanced chemical equation. Write what? A balanced chemical equation. So how do you write a balanced chemical equation? Right? How many calcium? Remember the calcium is what? It's solid. And it's a reversible reaction. So it's a reversible what? Reaction. So solid aqueous and aqueous. So my KSP here is equals to what? Concentration of the what? Of the cation raised by what coefficient. So it's going to be concentration of Ca2 plus aqueous raised by coefficient. My coefficient is what is 1 here, right? Sorry, we have not balanced the equation. How many calcium do you have here? So now let's balance the equation here. How many cation do we have here? Here we have one cation, one cation. How many flung do we have here? Here we have two, here we have one. So you have to put two at this point. Do you understand? So the next thing I want to do is yes, so write what KSP. KSP expression. And what I told you here, concentration of what? Of the cation based by coefficient. So it will be concentration of Ca2 plus aqueous based on 1, right? But they're not going to put 1 there. They have concentration of F minus aqueous based on what? 2. So this is what the KSP expression for what? This sort here. So we have done this one and we have done this. It's okay. Now the next thing I want to do here, these two that I have looked at are called monoatomic what ions. That is ions that are one, right? Now, but all the next one I want to look at that they are called polyatomic what ions. That is, if you check this guy, let's look at the C. Look at what the C. So here we have lead phosphate. It's okay, lead phosphate. Now that is why you must be conversant with. That's why you must be conversant with what polyatomic what ions. Now this one here we have a monoatomic ion which is what the lead, and here we have polyatomic ion which is what sulfate ion. Right there. So if you split it here, lead and what sulfate what ion. Right there. Now sulfate ion is only what 2 minus. SO4 2 minus. Right there. Now, when you're trying to split them into the various ion, try as much as possible to figure out one. Right there. Since I've easily figured out this guy here, this one will be much easier for me. If there's minus 2, this is the nature of this guy here, you're going to be what? Minus 2. Okay, because how do I know that it's minus 2? Because this 2 is what combined to form what this sort. You get? This 2 is what combined here to form what this sort. So if I should combine these two here to form this sort, then what I want to get? I want to get PB to XO4, which is what is 2. Can you see that? Now, remember, when you're writing ionic equation here, you must express them to the simplest ratio. 2 going to here, 1. 2 going to here, 1, right? So it can be 1 and what 1. Right there. So this will move here, and this guy will move here. So when you do that here, you have PB1 right there. Now this one are regarded as 1. So whenever you are writing it here, you have to put what XO4 1. This is that. But this one have no meaning, so it does not have any effect. So you have PBXO4. Can you see that? That is it. So in the sense that PB2 plus, supposed to be plus, not minus. PB2 plus and what SO4 2 minus is what from this what sort here. Do you understand? So now after figuring out this their various ion, so we want to do here so what to write a balanced chemical equation. So if you should write a balanced chemical equation, could be PbSO4, which is what? Solid. Then we're going to have what? Pb2 plus SO4 2 what? Minus, right? They are what? Both aqueous and what? Aqueous. Can you see that? So if you should figure it out here, the equation is what is balanced. Why is it balanced? Here we have lead, Pb, which is what 1. Lead which is what 1. SO4 is what 1. SO4 is what is 1. Do you understand? So if you want to write the KSP expression here, it's very easy. So here we have KSP is equals to what? Concentration of Pb2 plus aqueous. Now the coefficient here is what is 1, so you can ignore it. So you have XO4 2 minus aqueous. It gets for what? 1. Can you see that? So this is what the KSP expression for this compound here. Do you understand? So I'll be going to this one now. Then I want to try so then you take these two as assignments. Please, if you are following, if you are actually following this video here and this video is helping you to understand this thing here, please leave it at the comment section that you are following. But if you're not following, it's also leaving at the comment section that you are not understanding, so that I will look for a way to make it more simpler for you in the next video. But if this video is helpful so far, please leave a like and a comment. It goes a long way to tell me that you're actually following this video. So now let's look at what silver chromate. Silver what chromate? Called silver chromate. Ag2CrO4. So here we have Ag2CrO4. Now, like what I said earlier is that first of all, you must know your polyatomic ion. I get. So this CrO4 is a polyatomic ion. It's called radical. They are grouped as one. And the oxidation state is going to be CrO4 2 what minus. It's always like this. It only have two negative charge ion. I get two negative charge ion CrO4. Just like the way we have SO4 2 minus, SO3 2 minus, NO3 minus. I get. Here we have PO4 3 minus. It's okay. They are all polyatomic ions, so that's why you must know them. It's very important to know them. So if this guy is CrO4 2 minus, then definitely this one is going to be Ag plus. Now, why is it Ag plus? Remember, when you combine two of them will produce this as well as a product, right? So now let's confirm it. If Ag is plus and CrO4 is 2 minus. Now let's confirm it first. You can confirm it by writing the Ionic equation. So it will be Ag1 CrO4, which is what is 2. Remember, they are regarded as one. They are regarded as one. Do you understand that? They are what regarded as one. So this guy will move here, and this guy will move here, right? So you have Ag2. Now there must be in a bracket. So you have CrO4 bracket 1. But there is no point of putting 1 here. It's okay because it does not affect it. So here you have Ag2CrO4. So these two is what combined to form this other one here. Do you understand? So figure out the ions that form the salt is one of the most important things you must know how to do if you are writing KSP expression, because if you don't do that right, there's no way you're going to get it. So since we have figured it out, it means that here you're going to be solid, right? Then forward and backward the reaction. You have Ag plus aqueous plus what CrO4 2 minus, right? Now the next one to do here is to write a balanced chemical equation. Ag here we have 2, so you have to put 2 here. This is already 1, it's already balanced. Do you understand? Remember, Ks is equal to what? Concentration of the cation raised by the coefficient times concentration of the anion raised by the coefficient. Here's what my cation, here's what my anion, right? So we have Ksp equals to what? Concentration of Ag plus aqueous raised by what? 2, right? Then concentration of CrO4 2 minus raised by what? 1. It's okay. So this is what the KSP expression. Do you understand now? If you are following, please leave at the comment section that you are following. Now, this one will make us understand better. Do you get that? To make us understand better. So let's look at what the E part, the E. The E, here we have Mg3 PO4 2. It's okay. Now, like when I said, you have to what? You have to split. You have to what? Know their ion. Do you understand? Now, if you check very well, this was magnesium. Magnesium is always 2 plus. So magnesium Mg2 plus. Then. Now PO4 is a radical, and PO4 is what? 3 minus. So you have PO4 3 what? Minus. Then. So this 2 is what actually what forms this other one here. And if you check very well, you can see that this 2 is here and this 2 is here. How is it like that? This is when you're writing. This is when you're writing the ionic what? Is when you're writing ionic formula. So if you check very well, here we have Mg, which is what? 2, right? Now remember this one apply atomic ion, so here we have PO4, right? Which is what 3. Is it okay? Now because the apply atomic ion, you group them. So this guy move here and this guy move here. So when you do that, here we have Mg3. Now this one there in a bracket, here we have PO4 bracket. Here we have 2. Then I will form this other one. Do you understand? So you must know how to what split the salt into what their various ions, because this is the first thing. Now the next thing I want to do here is to what, to write a balanced chemical equation between them. So if I write a balanced chemical equation, remember this guy is what is solid. Here we have Mg2 plus aqueous plus what, PO4 2 minus, right? 3 what minus aqueous. It's okay. Now next I want to do now is to balance the equation here. How many magnesium do you have here? Here we have 3. How many PO4 do you have here? It's 2. So here we have 2, right? So you have to balance it. So my KSP equals to, now here we have constitution of Mg2 plus 2 plus aqueous raised for what? 3, right? Then we have PO4 3 minus aqueous raised for what? 2. So this is how to write the KSP expression. I believe you have understood this thing better here. So you go ahead and try these two for me. Is okay. That will be your assignment. You can leave it at the comment section. If this video is helpful, please leave it at the comment section that this video is helpful. And if you love this video, please leave a like and a comment. It goes a long way telling me that you are actually following this video. If you have a copy of this book here, please go ahead and order this book here for your personal study, because it will help you concentrate on what you are doing this semester. Do you understand? If you have any questions, leave it at the comment section. Thanks for staying to the end of this video. See you in next class.